COVID-19 has been a topic of intense discussion, primarily focusing on its impact on the lungs, heart, and brain. However, one area that has received less attention is how this virus can affect our pupils. Yes, those small openings in our eyes can reveal a lot about our nervous system health. The SARS-CoV-2 virus enters our bodies through ACE2 receptors, which are abundant in the lungs. But what many don't realize is that these receptors are also present in neurons and glial cells throughout the brain, making our pupils potential targets for the virus. The size of our pupils is controlled by the autonomic nervous system, which means that any disruption in the brain or nerves can manifest in pupil behavior. A recent study conducted by Turkish researchers examined 58 patients during their COVID-19 infection, and again 3 months later. They used high-precision devices to measure pupil size under different lighting conditions. The researchers were particularly interested in how quickly pupils responded to light changes, such as how fast they dilated after a light was turned off. The findings were intriguing. During active infection, pupils were significantly smaller in dim and medium light conditions compared to after recovery. However, under bright light, there was no noticeable difference. This suggests that something was affecting the autonomic nervous system's regulation of the eyes, particularly the sympathetic branch. Even more revealing was the pupil dilation response after light was turned off. Patients during their infection exhibited a significantly slower dilation response at every measured time point. This phenomenon, known as dilation lag, could indicate weakened sympathetic nerve activity or less inhibition from the parasympathetic system. Why does this matter? The function of our pupils relies on a delicate balance between signals from the brainstem, autonomic nerves, and the muscles that control pupil size. The study raises important questions about whether COVID-19 may cause disruptions in the central or peripheral nervous system, even in the absence of other neurological symptoms. It could indicate subtle brainstem involvement or even direct viral effects on the nerves controlling the eye. However, the study does have limitations. It didn't measure contraction speed, lacked bilateral simultaneous measurements, and didn't include certain confirmatory tests. Despite these limitations, the patterns observed are significant and warrant further investigation. COVID-19 might not just attack our lungs, it may also impact our nerves and brain, with our pupils serving as a subtle yet powerful clue. The question remains, should pupil tests be part of COVID-19 follow-up care? This is a conversation we need to have as we continue to learn about the long-term effects of this virus.